Hello everyone, this is my new geometry series. I still have my old geometry videos in the playlist titled old videos, so if you want you can go check that out as well. But I'm trying out something new, so instead of 30-minute long videos, I'll just be doing 5 to 10-minute long videos. This is going to be the starting of our geometry journey, so it's just going to be some basic definitions. And um, without further ado, we can get started in this topic. So the first definition is called a postulate. A postulate is basically a rule that is accepted without proof. There are many postulates in geometry, but what's more common is a theorem. So the main two things we have to contrast are postulates and theorems. A postulate is basically you don't need a proof. A theorem, you need a proof. That's basically the main difference between them. There's one more thing related to this, and that's a corollary. A bit hard to pronounce, obviously, and a little bit hard to spell, but it's basically spelled like this: a corollary to a theorem. So I'm just going to put that under theorem for now. A corollary to a theorem is basically a rule that can be derived from the theorem. As we go on in geometry, there'll be many examples of each of these. Less corollaries, to be honest, but a lot of theorems, mainly theorems, and a few postulates, few corollaries. With that out of the way, another important part of geometry is reasoning. And basically, you need reasoning to prove stuff. Proofs we're going to get into soon as well. But there are two main types of reasoning. The first type is called inductive reasoning. And this is basically based on a pattern. For example, if I had 3 circles, the first one was completely filled, the second one was half filled, the third one was a quarter filled, we can assume that there's a pattern. A pattern is also pretty important. It's basically like a noticeable rule-ish given to a series. In this case, it's a series of objects. It could be a sequence or a series of numbers, for example. And a pattern is basically when there's a noticeable rule to that. So in this case, the pattern would be that you're dividing by a half each time. So you start with 1, and then you go to half, and then you go to a fourth. So you're basically dividing by half each time. In inductive reasonings, there's a thing called a conjecture. A conjecture is the basis of inductive reasoning because it's basically an assumption made to prove something. And these are unproven statements like postulates, except they're not accepted. They're just unproven and assumed from the pattern. So conjectures are vital to inductive reasoning because you need to have this assumption in order to create a pattern. The other type of reasoning is called deductive reasoning. Deductive reasoning. Similar spelling, very different things actually. Deductive reasoning is kind of the opposite of inductive reasoning. Instead of using guesswork based on a pattern, you actually use laws and theorems that you already know. So, for example, you could have, given the sum of x and x plus 1 and x plus 2, prove that it's this sum is divisible by 3. And you can use deductive reasoning, you can use algebra to prove this. You add them up, you physically use variables. So you get 3x plus 3 is the sum of all of this. 3x is always divisible by 3 because it's always x times 3. Always there's a multiple of 3. And 3 is obviously divisible by 3. So this entire thing is divisible by 3. That would be deductive reasoning. For inductive reasoning, let me erase the previous examples so I can explain this example in using inductive reasoning. This is actually a pretty good example for both reasonings. So in inductive reasoning, we would list out some values. So let's say x is 1. So 1, 2, 3. The sum of that is 6, which is divisible by 3. Let's say 2, 3, 4. The sum of that is 9, which is divisible by 3. I'm just going to do one more. Let's say 6, 7, 8. The sum of that would be 21. Oh wait, let me is equal to 21. And that's still divisible by 3. So if you do this multiple times, you'll actually get a pattern. And you can use that pattern to prove the conjecture, which is that the sum of these three numbers would be divisible by 3. And in geometry, you're mostly going to see deductive reasoning because that's more official, in air quotes. It's not flawed. For inductive reasoning, and we're going to get into proofs soon, but in inductive reasoning, there could be a flaw. For example, 1 million, 1 million and 1, 1 million and 2, it's possible that that's not divisible by 3. In fact, it is divisible by 3, but and this is actually an accurate statement, but it's possible that there's one example that proves it wrong. With inductive reasoning, all you need is one example called a counter example to prove it wrong. You can have a million examples that fit the conjecture and one example that doesn't, and it'll still be a false conjecture. So with that out of the way, we just have a few more topics pertaining to proofs. A proof is basically, as I implied over this video, a proof is a logical argument, and it's usually done to verify a conjecture. So I'll give you an example of a proof. Let's say using the Pythagorean theorem. The Pythagorean theorem states that A, B, C are sides of a right triangle, then A squared plus B squared plus is equal to C squared. And this is usually taught in pre-algebra, but we're also going to be looking at the Pythagorean theorem in this course. It's part of geometry as well. And a proof of that could involve manipulating right triangles. Since we haven't learned right triangles yet, I won't go into an actual proof, but this is an example of a theorem that requires a proof. That's a proof. And then we have a few more definitions. There is something called a locus. And a locus, now we're getting to more geometry than proofs, and it seems like it doesn't have anything to do with proofs. It's basically a set of points that satisfies a condition. It kind of does, because usually when you have a proof, you want to prove something, you have a locus. For example, you can say the locus of all the points that are a given distance from a given point. Now that's the formal definition of a circle. Okay. Just like in the previous videos, my circles are very, very bad. Okay, let's assume that's a perfect circle. It looks a bit like a oval, but I'm not going to worry about that. This is the formal definition of a circle. It's all the points that are a given distance, r, the radius, from the center, C. And you would use locus to describe that, and you can also use locus in proofs, saying all of these points, the locus of these points, fit the condition. There is the intersection of two geometric figures. And two geometric figures can also be intersecting if they have an intersection. So briefly, an intersection is just the place where two geometric figures meet. Basically, the locus of points that are shared by those figures. If I have one circle here and another circle here, neither of those look like circles, but it's fine. The intersection would be this part, the one that I colored in, and it would be intersecting because it has an intersection. So those are basically some definitions in geometry. That was quite a few of them, and the video is already 9 minutes long right now, so that would be the end of this video. Next video I'll do in geometry would be about some postulates and rules that we would need in geometry. After that, we would go more in depth into reasoning, statements, proofs, and just wonderful stuff in geometry. So thank you for watching this video, and I'll see you in our next video. Bye.